Okay, so for this video, we are going to discuss the May June 2021 series paper 3-1. Okay, all right. So let us start with question number 1. So this is a question, okay, the inequality that involve modulus function at both sides. So for this kind of question, when I'm having modulus function at both sides, so usually when I want to solve it, I will square both sides. So which means that I will square the whole inequality. So I'm having 2 square multiply with 3x minus 1 square, okay, smaller than x plus 1 square. Okay, then of course you try to expand everything. Okay. All right. Then if you try to simplify and move everything to one side, eventually you should get 35x squared. Okay, so minus 26x plus 3. Then it is smaller than 0. All right, so when you do until this part, you will see that you get a quadratic inequality. Therefore, to solve the quadratic inequality, generally you have to try and get the value of x. All right, so you can factorize it if you want. Okay, so there are two values here where you can get x is equals to 1 over 7 and also x equals to 3 over 5. Okay, so to solve the inequality for quadratic, generally there are a few methods that you can use it. So for me, I'm going to draw the number line. I'm having 1 over 7 here and also 3 over 5. Okay, so to draw the arrow, I'm going to consider which part, okay, will give me the positive value. All right, so as an example, for the value 3 over 5, okay, so for is referred to this bracket 5x minus 3. So to make it positive, that means that any value that's greater than 3 over 5 will actually make this bracket positive. All right, so I draw the arrow to the right hand side, okay, of 3 over 5. And then for the value 1 over 7, it is referred to this bracket 7x minus 1. So to make the bracket 7x minus 1 to be a positive value, generally any value that is more than 1 over 7 will give this bracket a positive value. Therefore, I'm also drawing the number line to the right hand side from 1 over 7. Okay, so for the part with number line, it is positive. Without the number line will be the negative. Okay, so if you try to multiply the positive and positive together, then you have positive here, positive, negative together, multiply, you have negative, and then negative multiply with negative, you get positive. Okay, so again, to decide the final answer, right, you have to look at the quadratic inequality. What is the final sign that you have before you want to draw the number line? So for here, you can see that you want something which is smaller than 0. So smaller than 0 means that you want a negative value. Anything smaller than 0 means negative, right? Okay, so I'm looking for the range of x where they will provide the overall negative value. Okay, so from here you can see that the answer for the x should be between 1 over 7 until 3 over 5. So this will be the final answer for this modulus function inequality. Okay, so now we come to question number 2. They give you this equation and they want you to find the real root of this equation. So giving your answer correct to 3 decimal places. Okay, so now for this particular equation, maybe you can write it out first. Okay, so from here you see that it is a fraction originally. Okay, then to solve it in an easier way, I will bring the denominator to the other side. And therefore, I'm having 2 plus ex here. Okay, so for this one, actually, if you can see, the common terms that you can see here is e power x, e power x, e power negative x. All right, so if you cannot see clearly, right, you can actually try to substitute e power x with one unknown or maybe one other letters variable. Okay, so you're having, let's say, y equals to ex. So you're having 2y plus 1 over y, because e power negative x means 1 over ex, right? So you're having 1 over y equals to 6 plus 3y. And again, I don't like the denominator here, the y. So I will bring it up and multiply with every single term with y. So you're having 2y squared plus 1 equals to 6y plus 3y squared. Okay, then you try to rephrase it. Right, so when you try to rephrase it, you will get this one, y squared plus 6y minus 1 equals to 0. Okay, so you actually get a quadratic equation. For here, you can see that it is in terms of y lah. But generally, you know that the y is actually e power x, right? It is still a quadratic equation, but it is actually in e power x. Okay, so when you want to solve the quadratic equation, there are a few ways for you to solve it. So for this one, you cannot do factorization if I'm not mistaken. So what you can do is that you can apply the quadratic formula. So to get a quadratic formula, how you get a quadratic formula? Okay, so to get the e power x, you need to put in the formula, right? So negative b. So negative b is negative 6. Okay, so b is the coefficient in front of the y or in front of the e power x. So negative b plus minus b square. Okay, so b square minus 4. A is a 1. C is negative 1. Then divided by 2a. Okay, so for information, the a is here. Okay, this is the a, all right, where it is 1. And then the c is this one, which is negative 1. Okay. All right, so of course you can try to continue and simplify it. Yeah, so if you try to simplify everything, right, eventually you will get two values here for e power x. The first one will be negative 3 plus square root 10. Another one will be e power x equals to negative 3 minus square root 10. Okay, so actually we should ignore this, and we can't get the answer lah. All right, why? Because e power x should be more than 0. But you can see that the equation here, okay, the value on the right hand side is a negative value. So e power x must be a positive value. So that's why you cannot get any solution from this part. Okay, then after that, we come back to the first value here, negative 3 plus 10 plus square root 10. Okay, so to get the e, you need to take ln both sides. Okay, so when you take ln both sides, you are having x equals to ln, then negative 3 plus square root 10. And since they're asking your final answer, the real roots in 3 decimal places, right? Okay, so you can just press the calculator and try to get the answer lah. So you should get negative 1.818. So this is the only one answer that we have, okay, for this real roots for this equation. All right, so question number 3. Okay, so for question number 3, they give you the equation that involve trigo lah, and they want you to show that this equation can rephrase become this one, right? Okay, so from here you can see that these two equations actually involve the compound angle, right? So you actually have to apply the compound angle formula. So what's the compound angle formula that we have here? We need to use here is this one. When you're having cos A minus B, so when you try to expand it, it will be cos A cos B plus sine A sine B. Okay, so you can look for the formula provided in the formula booklet. All right, so this is actually the compound angle formula. Okay, then when you're having the sine, sine A plus B. So when you want to expand it, it will become sine A cos B plus cos A sine B. Okay, so these two are the formula that we are going to apply in our question here. Okay, so from here you can see that we are having cos x minus 30. So you can see that the A in the formula will be the x. Then the 30 here will be the B. So the same thing happens for sine. This is the A and also this is the B. So when you want to expand it, you just substitute all the value provided in the question, okay, to the formula. Right, so let's start. Okay, so first of all, we are having cos x minus 30. Okay, that equals to 2 sine x plus 30. Okay, so when you expand it, you will have cos A cos B. Okay, then plus sine A sine B. And it is equals to 2 sine A cos B, then plus cos A sine B. Okay, so once you ensure that you substitute the formula correctly, all right, then you can try to substitute in the value that you can get it from the trigo. As an example, like cos 30, you'll get a value for cos 30. Sin 30 also the same, you'll get a value for sin 30. Okay, so for cos 30, it will be square root 3 over 2. Then cos x. Okay, sin 30 it is actually half, so you're having half sin x. Okay, so for the right hand side here, cos 30, again, it is actually square root 3 over 2, right? And you multiply 2 inside and you are having square root 3 sin x. Okay, then sin 30 is a half. Right, so sin 30 is a half, then you multiply with 2. What do you get here? It will be a 1. So you have cos x eventually. Okay, so next step, you look at the answer that they want. They actually want you to get something related to tangent x. So to get the tangent x, you should try to think about sine x over cos x. All right, so for the whole equation here, you can try to group sine x one side, cos x one side. Then you rephrase everything if you want. Okay, or you can straight away divide the whole equation with cos x if you want. So that's another option for you. Okay, all right, so maybe for now I will try. Okay, so like this one, I have a 2 as a denominator, right? So again, maybe I don't like this. I will make it as multiply the whole equation with a 2. So I'm having a good looking equation. Okay, plus 2 cos x. So this is one method, okay, one of the method, but of course you have a lot of different methods that you can apply as long as eventually you can get what they want you to prove to do, right? Okay, so for this one, I get a equation without any fraction. Okay, then the next step is maybe for the whole equation, I will want to divide them by cos. Okay, or some students will say that I want to group all the sine x one side, all the cos x to the other side. Then only I make it become tangent, also can. All right, so it depends on which one you prefer. All right, so when you divide the cos x for the whole equation, then you're having square root 3 plus tangent x equals to 2 square root 3 tangent x plus 2. Because from here, you should know that sine x divided by cos x, you will get a tangent x. Okay, and now I will want to group all the tangent x to one side. So I'm having tangent x minus 2 square root 3 tangent x equals to 2 minus square root 3. So from here, you can take out the tangent x. And I think you can see the answer very clearly already. So if you move all the value to one side, Okay, so you will exactly get what they want you to prove here. Okay, all right, so this is how we actually prove it. All right, so maybe from when you are trying to move on, right, from the solution from every single step, sometimes you need to have a look for the final answer and think how are you going to get the tangent x first. Okay, all right, so this is what we have for part A. Okay, then now we continue to part number B. Okay, so for part B, this is the question for part B. Okay, and they want you to solve. Okay, they want you to solve the equation. Okay, for x is between 0 until 360, so that means one cycle. Okay, so again, if you try to compare part B, this equation and actually this equation is the same. And usually when they ask to prove that this equation equals to something else, that means you have to use the answer, the proving part here, the answer here, okay, to continue with the solution. So you have to solve this equation actually. Okay, so for part B, when you are having tangent x equals to 2 minus square root 3, okay, 1 minus 2 square root 3. So first of all, you have to try and press the calculator. Okay, so for this one, this value itself, please take note that when you press the calculator, it is actually a negative value. Okay, so when you want to get the x for tangent with a negative value, right, you need to know that negative value for tangent is in second quadrant and also the fourth quadrant. So later when you want to find the x, you only want to consider the second quadrant and also the fourth quadrant only. So to get the answer from second quadrant, it is 180 minus the basic angle. So for quadrant number 4 is 360 minus the basic angle. Okay, so now let us start. To get the basic angle, okay, so of course you should press tangent -1. Ignore the negative value for this term. All right, so maybe you can make it become square root 3 minus 2 divided by 1 minus 2 square root 3. Ignore the negative value because I want to make sure that my basic angle is always in the first quadrant. All right, so I will always make the value become positive first. All right, then you will see that the basic angle is 6.2. So the 6.2 degree here is actually the theta. That's what I mentioned inside here. So the theta will be the basic angle. And therefore, to get the x, you need to consider the second quadrant and also the fourth quadrant, right? So the second quadrant will be 180 minus 6.2 degree. Fourth quadrant will be 360 minus 6.2 degree. So eventually, the final answer for the x is 173.8 degree and also 353.8 degree. Okay, so this is how we actually get the value for the x. Okay, so for now we are going to discuss the question number 4. Right, so for question number 4, part A, they want you to prove this equation. All right, so now it is that involve three goals. Okay, so maybe for us, where should we start? So for me, I will start with the left hand side. Okay, so what helps me to decide that I want to start it from the left hand side? So usually for me, I will actually look at the terms on the left. Okay, so for this one, you can see that you're having the double angle formula and you can try to expand, okay, the double angle formula to make it become theta. And after that, you can rephrase it into theta on the right hand side. So instead of you want to group the theta to double angle, it is much more harder. So usually I decide from this, by using this way. All right. Okay, so we are having the double angle formula. Okay, so you're having cos 2 theta, both on top and the bottom part here. Okay, so what are the formula that you can consider when you're having cos 2 theta? All right, so there are a few formula for cos 2 theta. The first one is 2 cos square theta minus 1. You can consider to use this. Another one is cos 2 theta equals to 1 minus 2 sine square theta. Okay, so from the equation that I have here, I want to get tangent square theta on the right hand side at the end. So I want to have tangent square, and I know that tangent square is something related to sine square divided by cos square. Okay, so later when I choose the formula, I need to choose it carefully. Okay, so I will start from the left hand side. Okay, so the left hand side, I'm having 1 minus cos 2 theta, and then divided by 1 plus cos 2 theta. Okay, and then which is the correct formula that we should use? All right, so since I mentioned just now, the right hand side, I want to have sine on the top, then cos at the bottom of the fraction. So from the double angle formula that we have, I think on top we should try to apply this one. Okay, then we should keep the cos square theta at the bottom. So if you substitute it inside your equation, your expression, then you're having 1 minus, okay, then 1 minus 2 sine square theta. Okay, then for the denominator, cos 2 theta, you want to substitute it by using 2 cos square theta minus 1. All right, so if you try to further simplify it, okay, you will see that actually you will have 2 sine square theta divided by 2 cos square theta. And of course, the 2 and 2 can be cancelled off with each other. And after that, what do you have here will be sine square divided by cos square. And this is how you get tangent square theta. All right, so from here, we actually try to expand the double angle formula, okay, for cos square theta. And after that, you simplify to get the tangent square theta. Okay, so we done part number A. Then now we continue to part number B. Okay, so for part number B, they want you to find the exact value. So again, for the exact value part here, you need to keep your final answer either in the cert form, in the pi form, in the e form, and so on. All right, so it cannot be written in a long decimal places. Right. Okay, so this is our equation here, our expression here. So again, if you look at the expression here, this term, this expression is actually what we have in the first part. Okay, so again, the style of the question is like this. For the first part, when they ask you to prove something, right, generally you need to apply in the second part. Okay, all right, so we will start from here. I'm having pi over 3 divided by pi over 6 for this expression. Okay, and then since I know this expression is equals to tangent square theta, so I will substitute it by using the tangent square theta. So for this kind of question, actually they are trying to hint you, right? How are you going to change your equation into something that you can simplify it, okay, or you can integrate it. All right, so how can I integrate tangent square theta? All right, so you cannot integrate the tangent square theta straight away or straightforward, but you can maybe consider to change it to some other identities. All right, so for the identity that related to tangent square theta, what can I think of is from this basic identity here, cos square plus sine square equals to 1. Okay, then if I want to have tangent square, I need to divide the whole equation by cos square, right? To get the tangent square in my equation, in my identity. So sine square, okay, sine square divided by cos square, I'm having tangent square. Okay, cos square divided by cos square equals to 1. 1 divided by cos square, you have secant square theta. All right, and therefore, for tangent square theta, you can rephrase it as secant square theta minus 1. All right, so I cannot integrate the tangent square straight away, tangent square theta straight away, but I can actually integrate this one, right? I can integrate secant square theta, which will become the tangent theta, because differentiate tangent, you get secant square, right? So it is opposite process. Okay, then for the one, when you want to integrate, you straight away get the data here lah. So this is actually the terms or maybe the expression that I can do the integration straight away. So I will substitute the tangent square theta by using this identity. So tangent square theta can be written as secant square theta minus 1. Alright, so when you try to integrate secant square theta, you got tangent theta. When you integrate 1, you get the theta. And you need to substitute the limit now into the equation and try to rephrase them. Okay, alright, then now, how can we continue with all this? Okay, substitute tangent pi over 3, which is tangent 60 degree, then minus pi over 3, and after that tangent pi over 6, okay, minus pi over 6. Alright, so since they want you to have the exact value, and if we are using the MS calculator, right, for Cassia 570 MS calculator, you need to draw the triangle to help you. Alright, so I'm having pi over 6, 90 degree, and also pi over 3. So for pi over 6 is 1 over 2, and this is square root 3. Alright, so you need this triangle to help you to get the exact value. Alright, so tangent pi over 3. What is the tangent pi over 3 that you have? It will be square root 3 minus pi over 3. What is tangent pi over 6? It will be 1 over square root 3. Okay, then plus pi over 6. Okay, and after that, please take note that I want to group all the terms with the square root 3, the third 3, okay, together. So this one actually is a problem for me. Okay, so 1 over square root 3, I want to rephrase it so that the denominator has no square root 3. Therefore, what you need to do is I need to rationalize, okay, the fraction. Okay, so when you rationalize the fraction, you are having 3 and then square root 3. So for this term, when I want to substitute it back, I can write it as 1 over 3 square root 3. Okay, so for this one, I will put it back here. Okay, and after that, if you continue further, I'm having negative 1 over 3 pi plus 1 over 6 pi. Okay, so you can treat all the third 3 as an apple. So third 3 means 1 apple minus 1 over 3 apple, and you are having 2 over 3 apple. Okay, then negative 1 over 3 pi. Again, you can assume the pi is an orange plus 1 over 6 orange, the pi. Okay, so by pressing the calculator, you should be able to get negative pi over 6. So 1 over 6 pi. Okay, so if you want to rephrase it in a fraction form, then you can write it like this if you want. Alright, so this is how we actually keep our answer in the exact value for this integration. Okay, so let us continue with question number 5. Alright, so question number 5 for part A, they want you to solve this equation and where P and Q are real constants. So since we can see the I, okay, we can see the I, okay, and Z, all these things here. So generally, like, when you see the I, you know that it is actually a complex equations, right? That might involve the complex roots, okay? And then you can see the Z square and then the Z here, okay? The Z square and the Z here. Generally, it also tells you that this is a quadratic equation, okay? All right. So generally, this is a quadratic equation, but because of the coefficient involved, the I. Alright, so therefore we cannot factorize it to solve it. Okay, so to solve this equation, generally the only thing that we can do is like we can use the quadratic formula, alright, which is negative b. So the b here will be 2pi, okay, plus minus square root b squared. So the b squared will be 2pi squared minus 4ac and divided by 2a. Alright, so we try to simplify everything here. I'm having 2pi, then plus minus square root, Okay, so negative 2 squared become a 4. P is p squared. Then I squared is negative 1. Therefore, if you try to simplify everything here, you will have negative 4p squared. Alright, and then plus 4 cubed. Then divided by 2. Okay, then if I want to further simplify it, I can see that there are both terms inside the square root has 4. So what can I do now is I can try to factorize out the 4. Then having the cube minus p squared divided by 2. Okay, so continue further. Alright, so the third form or square root 4 tells you that you can simplify become 2. And then you keep the cube minus p squared, okay, in the third form and then divided by 2. Alright, so here you can see that all the 2, okay, in the fraction can be simplified and end up you're having two answers here. The first one will be pi plus square root q minus p squared. This is your first root. And the second root will be pi minus square root q minus p squared. So these are the two roots that you have, okay, when you want to solve the equations shown in the question just now. Okay, so very obvious, you can see that your roots, the roots that you get is actually the complex number. Okay, all right. Then now let's continue to part number B. So they tell you that in the Argand diagram with origin O, the roots of this equation are represented by the distinct points A and B. So there are two distinct points here. Okay, so you can imagine that, okay, let's say simply assume that this is A and this is the B. All right, then now they said given that A and B lie on the imaginary axis. Okay, so now if let's say they tell you that both A and B lie on the imaginary axis, so that means if you try to sketch the Argand diagram, right, you might have something like this. A and B are on the imaginary axis. Okay, which means what? Which means that the coordinate for A and also the coordinate for B, it should be something like 0 and then AI. And also 0 with BI because they belong to y-intercept. All right. Okay, sorry, I should write it as 0A and 0B. That means the x coordinate should be a 0. Okay, and then the value here only have value on the imaginary axis. And if you want to write A into the complex number form, that it will be 0 plus AI, or the B will be 0 plus BI. Okay, so this is something that you should know, right? If you want to fulfill what they tell us here, the both roots lie on the imaginary axis, right? So you have to ensure that when you try to rephrase everything in your roots A, the final answer will be 0 plus AI. That means the real component, okay, the real part must be a 0. And then only you have value at the imaginary part. The same thing happen for part B, the point B also, or maybe the root B. Okay, all right. So now let's come back to this one. So let's say just now I already told you that A should be equals to pi plus square root q minus p square, right? Okay. What I need to do is like I have to make sure that this term. Okay, so maybe I use other color. This term, okay, must have something with I. Okay, so can be expressed as something I. So as example, maybe you can put it as HI, something like that. Okay, so to rephrase this term, become the HI, or HI is a high, right? Maybe we put some other value, KI or whatever. All right, so how can I change this term, only this particular term, become a complex number KI? All right, so to make this one, into KI, you have to make sure that the terms inside the square root, okay, must be a negative. Because if you have negative, then later when you rephrase it, right, you will have square root -1. Then we have square root -1. You can rephrase it as something I later. Okay, all right. Okay, so now, since I already know that I want to have q minus p square, okay, must be a negative value, so it makes me, or maybe it shows that we have to show that q minus p square must be smaller than 0. Okay, because when q minus p square smaller than 0, then you have square root negative something something something, then you can put it as square root something 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 I. Okay, so this is our main objective for here. Okay, all right, so that's why I must let q minus p square smaller than 0, and therefore I will get q smaller than p square. So this is the relation between the p and also the q. All right, so the main idea is from here. The imaginary axis tells you that your root must have only the imaginary part. So to make this term as imaginary part, you have to make sure that the value inside the square root must be smaller than 0. And from there, you get the relation, which is q smaller than p squared. Okay, so this is what we have for part number B. Okay, then now let us continue to part C. Okay, so for part C, given instead that the triangle OAB is equilateral, express Q in terms of P. Okay, so now they want you to forget about the part B here. All right, so now the OAB is actually an equilateral triangle. All right, so just to remind you all, okay, let's say I'm having A. What are the point? This is point A, right? What is the coordinate for point A? So let's say I assume that it is Z1. So for the first root that we get just now, it is actually square root q minus p square plus pi. Let's say assume A is this point lah. And then B, I assume that it is Z2, which is square root q minus p square minus pi. Okay, so this is what I assume here. And then, no, right? Okay, sorry, I make a mistake here. So maybe for B is actually negative. Sorry, it is a negative. Okay, so again, this is negative square root q minus p square plus pi. Okay, so these 2 points, actually I get it from part 1. Okay, I get it from part 1. Yeah, so it is confirmed that both are pi lah. All right, so the square root part, okay, we are having one positive and one negative. Okay, then let's continue. Okay, once I know that these 2 are the Z1 and Z2, which is point A and point B already, maybe you can try to roughly show, okay, the Argand diagram if you want. Okay, so very obvious, this is my origin 0, 0. Okay, then you can have a look for this one. Q minus p square root, if it is a positive value, right? So it should be a positive value x plus pi. So maybe what can I do is that I can label this as square root q minus p square. Okay, and then I'm having a point here. Okay, then this point is actually point P. This is the value P lah. Okay, this is imaginary and this is real root. Real axis. Okay, so this is point A actually. All right, then for my Z2, so the Z2 is negative square root q minus p square. So the negative q minus p square will be somewhere here on the left hand side, negative q minus p square, and then the y coordinate is still the p. Okay, and this is the point B. And then they said point A, B, and also O form the equilateral triangle. So the triangle form will look something like this. Okay, and then since they are equilateral triangle, right? So that means now all the length for the 3 sides are the same. Okay, are the same. All right. Okay, then besides the three sides having the same length, okay, you also know that the angle, okay, for what we have inside the triangle will be 60 degree. Okay, and because of this is also 60, right? Okay, that according to the rules that we learned before, some basic properties. Can you see the Z here? Okay, so this line and also the real axis are parallel. So it also makes us know that this point itself, this angle itself is 60 degree. Okay, all right. So this is the information that we can get from the question. They told us that we want to have a triangle OAB and they are all equilateral. They are equilateral triangle. So that means the angle inside the triangle are all 60 degree. Okay, so now they actually want you to express Q in terms of P. So maybe for me, right, I will focus on this angle here. Okay, so what is this angle? So this angle is actually the argument of A, or maybe of Z1. All right, okay, because you can see that this is point A, right? So to measure the argument, okay, you measure it from the right hand side of the x-axis, then measure up. So very obvious, this is the argument of A, or the argument of Z1. All right, so what is the formula for the argument of Z1 in the first quadrant? Okay, so in the first quadrant, to get the argument, it is actually tangent inverse B. So the B is this one. Okay, so tangent inverse P divided by A. So the A is the real part of the complex number, which is square root Q minus P square, and it is equals to 60 degree. Okay, then now the tangent inverse, I think I will want to move it over. Okay, so I'm having tangent 60 degree. Okay, all right. Then now I want to try to simplify everything here and express Q in terms of P. Okay, so what is tangent 60? So tangent 60, I get square root 3. Then I move the square root Q minus P square over. Okay, then I can combine these two surd together. And eventually, I can square the P here. And then I'm having 3Q minus 3P squared. All right, so I think very easily you can get 3Q equals to 4P squared. And finally, what you get is Q equals to 4 over 3P squared. Okay, so by just using one argument of A, right, you can get the answer. You can get the relation between the Q and also the P. Okay, so now we are at question number 6. Okay, so for question number 6, they give you the parametric equations. And then first part, they want you to show that the gradient of the curve is always positive. So again, when you see the word gradient, it tells you that it is actually the dy over dx. Okay, so very obvious that you need to do the differentiation, okay, to get the dy dx. All right, so first part, you need to do the differentiation separately for x in terms of t and also the y in terms of t. Okay, so first part, I'm having x equals to ln 2 plus 3t. And then when I want to do the differentiation towards t, okay, so I will have dx over dt. So the dx over dt here, I'm getting the whole bracket inside the ln, I will bring it down, become the denominator. And after that, I differentiate the thing inside this bracket. And I will get a 3, right? So I'll multiply this answer with 3. Okay, so this is what we have for dx dt. Okay, then for the y, okay, y I'm having equals to t divided by 2 plus 3t. It is a fraction with t, okay, for both numerator and denominator. Therefore, when I want to do the differentiation, I should apply quotient rule. Okay, so to apply the quotient rule, the step will be you square the denominator, copy the bottom, that means copy the denominator, differentiate the top, you get a 1. Then minus, you do it the other way around, you copy the top, differentiate the bottom. So that means you differentiate the original denominator. Right, so the original denominator here will be 2 plus 3t. When you do the differentiation, you get a 3. Okay, all right, then after that, you try to simplify it. Okay, so I'm having 2 plus 3t minus 3t and divided by 2 plus 3t holding square. So you'll get a simple fraction here, something like this. Okay, all right, then because of they are asking for the gradient of the curve, so I will continue with the chain rule to get the dy dx. So to get dy dx, I'm having dy over dt multiply with dt over dx. Okay, so for dy over dt, it is 2 over 2 plus 3t squared. For dx over dt, it will be 2 plus 3t divided by 3. Okay, so from here, you can see that you simplify the whole thing, the square with this whole terms, the expression on top. Okay, then when you try to rephrase it, then what you get here is 2 over 3 and then 2 plus 3t. Okay, so this is your dy dx, your gradient. Okay, but here they actually want you to show that the gradient of the curve is always positive. So how can I show that it is always positive actually? Okay, so now from here you can say that you can see that you're having 2 plus 3t like in your answer. Okay, and then if you refer to the original parametric equation, right? The x you are having ln 2x plus t. Okay, so you can try to link this together. So since x is equals to ln 2 plus 3t, okay, therefore the 2 plus 3t must be always positive, must be always greater than 0, okay, so that the ln function is defined. Because if you're having the 2 plus 3t equals to a negative value, right, then the ln function will not be defined. You'll get a math error. Okay, so from here you know that the 2 plus 3t greater than 0 must be 2 plus 3t must be positive, must be greater than 0, so that the ln function is defined. And since the 2 plus 3t must be positive, right, so that also means that dy dx okay, the dy dx equals to 2 over 3, 2 plus 3t is always more than 0 as well. Okay, because of these terms. All right, because of this one, because you know that 2 plus 3t is always greater than 0, and therefore the dy dx is also always greater than 0. So maybe you can write it something like this. So the dy dx is always positive. Okay, so you need to tell them the reason, because if let's say without saying the reason, then actually the t can be any value. But if you look at the original parametric equation, then you have to make sure that 2 plus 3t must be positive so that the ln function is defined. Okay, all right, then now let us continue to part 2. Okay, so for part B, okay, what they want is they want us to find the equation of tangent to the curve at the point where it intersects the y-axis. Okay, all right, so maybe before we start, we try to rewrite again all the important information here. Okay, so what is the original formula for x? X is ln 2 plus 3t. Okay, then what is the y? Y is t over 2 plus 3t. Okay, and just now you got the dy dx, right? So what is the dy dx? The dy dx will be 2 over 3 then 2 plus 3t. Okay, so now, okay, because of they mentioned that the point where it intersects the y-axis. So for the point where it intersects the y-axis means that it is the y-intercept and also x is equals to 0. Okay, so from this information, then we can start. All right, so when x equals to 0 means that you're having something like this. 0 equals to ln 2 plus 3t. Okay, so ln you move it over, become e power 0 equals to 2 plus 3t. E power 0 is a 1. And therefore, from here, you'll get the value of t. So the value of t is actually negative 1 over 3. Okay, so when t equals to negative 1 over 3, what is the value of y? Okay, so the value of y will be y equals to negative 1 over 3 divided by 2 plus 3 negative 1 over 3. Okay, and eventually when you try to simplify it, your y here that you get is actually negative 1 over 3 also. Okay, all right. So now what is the coordinate? Then again, coordinate is coordinate of the point. So the coordinate of the point is actually x and y. So don't be confused with the t here. So for the coordinate, it will be 0 and also negative 1 over 3. So actually what they want is they want you to find out the equation of the tangent at this particular point. Okay, all right. Then after that, you get the coordinate already. You want to get the gradient. So the gradient of tangent is dy dx. So again, you substitute the value of t into the dy dx. So you're having 3, then 2 plus 3, negative 1 over 3. Okay, so if you try to continue, your dy dx will be 2 over 3. Okay, so please take note that this particular value itself is actually the gradient of tangent. All right, so since you have the gradient of tangent already, and you also have the coordinate already, then to form the equation of tangent, you just apply the linear formula, right, for the line, for the straight line. So equation for tangent. Okay, so for me, I'm using y minus y1 equals to m. M is the gradient, then x minus x1. So if you continue from here and rephrase everything, then you should get 2 over 3x minus 1 over 3. And this particular equation is actually the equation of tangent, okay, for the curve at the point where it intersects the y-axis. Okay, so now we come to question number 7. Okay, the diagram shows that you are having this curve and the maximum point is at M. And the x-coordinate for M is actually A. So now they want you to show that A satisfies this equation shown here. Okay, so so this question they are talking about the maximum point actually. Okay, so every time when you want to find the maximum point, we need to do the differentiation. All right, so we are having y equals to tangent inverse x divided by square root x. Okay, so to do the differentiation here, because it is a fraction, right, with x at both numerator and denominator, so what we are going to do is that we have to use the quotient rule. Okay, so to use the quotient rule, we are having square root x squared, and you copy the denominator, original denominator, then you try to differentiate the tangent inverse x. So when you do the differentiation for tangent inverse x, you should get 1 over 1 plus x squared. Okay, then minus. Now you copy back the tangent inverse x, but you differentiate the original denominator, which is the square root x. Right. So what is the differentiation of the square root x? You will have half, and then x, the power minus 1 become negative half. Okay, all right, and then because you are finding out, you want to find out the the x coordinate for m, right? Okay, and they want to show that A satisfy this equation. So when you want to find the maximum point, you let dy dx equals to 0. Okay, and then from there you will have, all right, so you will try to have those A inside the x here. Okay, all right, so if let's say I let dy dx equals to 0, then square root x, square root x squared, when I move it up, it will become nothing. Okay, so I will only now focus on the numerator. So for the numerator, I will have square root A divided by 1 plus A squared. Okay, then minus 1 over 2 square root A, and then tangent inverse A. So that means when you substitute the value A inside the equation, when you let dy dx equals to 0, right? Eventually, you able to get this one. Okay. All right. So maybe you just need a little bit of planning before you want to continue the step. Okay. So in our step here, we are having tangent inverse, but in the final answer, they have tangent. So that means the tangent inverse, you need to move it over later. All right. So that it becomes a tangent. So what am I going to do from this step is I will group, okay, the tangent inverse at one side. Wait. Okay, so I will put it like this. So I'm having tangent inverse A. It is equals to square root A divided by 1 plus A squared. Okay, then of course I will move the 2 square root A over. Therefore, my tangent inverse A will become 2A divided by 1 plus A squared. Okay, then very obvious that if you bring the tangent inverse over, it will become tangent 2A divided by 1 plus A squared. So this is something that they want you to prove. Okay, so A fulfill this equation actually. Okay. All right. Okay, so this is what we have for part number A. Okay, then let us continue with part number B. Okay, so for part number B, they want you to verify that the A lies between the value of 1.5 and also 1.3, 1.3 and 1.5. Okay, so for this kind of question, generally they want you to show the sign change method. Okay, so to complete with the sign change method, first of all, you have to look at the equation that they provide you just now. Okay, you make it into a expression or into a function. So maybe for me, I'll write as FA equals to A minus tangent then 2A divided by 1 plus A squared. So this is my FA. And therefore, to get the sign change value, I will need to put in the 1.3 into this function. Okay, so please take note that if you want to get the correct answer, right, okay, you have to put your calculator in radian mode. All right, all the values that we measure here are into the trigo, especially you have the trigo expression. Okay, so all these are actually radian. It is not in degree. All right, so for me, I'll always put it into the radian mode, and therefore I will try to calculate the value by using calculator. Okay, so you substitute the 1.3 into the function. Okay, so eventually what you get is you should get a value 0.4148. Okay, then if you substitute 1.5, okay, when you press the calculator, then you get 0.178. Okay, and then from here you can see the sign change up because when you substitute 1.3, you get a negative value. When you substitute 1.5, you get a positive value, and therefore you can make a conclusion here. Okay, so you can say that there's a sign change. Okay, sign change can be seen between the function 1.3 and 1.5. Okay, so it means that A lies between 1.3 and 1.5, which means that if you substitute A into the function, right, you should get a 0. All right, so since you get 1.3 is negative, 1.5 is 1.3 is negative, 1.5 is positive, right? So that means down to A. You put in the A equals to 0 should be between 1.3 to 1.5. So this is how we prove. Okay, verify by calculation that A lies between 1.3 and 1.5. Okay, then now we proceed further. Okay, to part number C. All right, so for part number C, they want you to use an iteration formula based on the equation in part A to determine A correct to 2 decimal places. Okay, your final root will be in 2 decimal places, and each iteration have to be 4 decimal places. Okay, all right, so let us start. Okay, so now you can decide what is the initial value that you want to put in for A1. Okay, so usually I will suggest that you can refer to the part B just now. For sign change method, right, you already know that your roots is between 1.3 and 1.5. So you can choose any value between these two. Okay, or any value between that means you can choose 1.4 also if you want. All right, as long as it is from here. All right, so to me, right, if you choose the correct value from here, at least your steps will be slightly shorter. Okay, if you choose a wrong value, then you might need more iteration to get the answer. Okay, right, so now let us start. Okay, so please take note that when you want to get the answer, okay, maybe for my A1, I will put it as 1.3 lah. I'll put it as 1.3. This is my initial value, right? Okay, then now I need to key in the iteration formula. Okay, so what is the iteration formula here? It is tangent. Okay, then 2a. So 2a means that I'm having 2 and then x. All right, then divided by 1 plus a squared. So I'm having 1 plus a. So the a will be the x and then squared. Okay, all right, then after that before I do any calculation, I will double check with the mode here. So can you see a small r here? So that means this calculator is in the radian mode before I do any calculation. Okay, all right, then now if I put in the okay, so maybe now I want to get the a2, right? Okay, so to get the a2 you are going to substitute 1.3. Okay, so into the iteration formula. So you're having 2 multiplied with 1.3 divided by 1 plus 1.3 squared. Okay, so just now you already key in the value, the key in the formula, right? Okay, so now you want to calculate the answer. So now please press on the calculate button here. They are asking you what is the value of x that you want to input. So please input 1.3 and then you press equal sign. All right, so from here, the calculator show you 1.4484. So 1.4484. Okay, so I will write my iteration into 4 decimal places. So this is my A2. Then now I want to continue to get an A3. Okay, so for A3, we are going to use the similar formula and the same step. Okay, press on the calculate button in calculator. And again, they will ask you what is the value for x that you want to input. So now we will input this one, 4484, sorry. Okay, and you press equal sign, and you get the next value for 8, which is 1.3552. So you can write in the value straight away, 1.3552. You have to make sure that all your iteration, when you write out, it must be 4 decimal places as requested in the question. Okay, right, then now let us continue the same process. Okay, press calculate again in your calculator, and then you input the value 1.3552. Okay, then press equal sign, and the next one will be 1.4148. Okay, so from here you have 1.4148. All right, so now if you want, you can double check with your 2 decimal places answer. So for this one, you get 1.45. This one, you get 1.36. So 1.45 and 1.36, they are not the same answer, right? So that means it is not the root yet. Then if you continue further, this one is 1.42. So 1.42 and 1.36, they are not the same answer yet. so it is not the root yet. Okay, so you have to continue to get it until the root appears. All right, so next steps, still the same, next iteration, press the calculate and then you key in this A4, which is 1.4148, and press equal sign. And then for this question, for this iteration, you get 1.3769, which is 1.3770. All right, to 4 decimal places, so 1.3770. So again, very obvious, it is not our final answer yet. Okay, then continue again. Calculate 1.3770. Then press equal sign one more time. And then you get 1.4011. So 1.4011. Is it the answer already? So again, if you double check with the 2 decimal places, they are not the repeated value yet. So we will continue until we get a repeated 2 decimal places value. Right, then calculate again. 1.4011. Then equal sign. Okay, then next one is 1.3858. So 1.3858. Then 88. Okay, continue. Calculate 1.3858. 1.3858. All right, then press equal sign. 1.3955. So 1.3955. Okay, so from here, it is still not the repeated value yet. All right, but it seems like it is almost the same already, not a big difference anymore. So you can maybe just continue again. Okay, so calculate, then 1.3955 equal sign. Okay, so 1.3893. So 1.3893. Okay, then next one, calculate 1.3893, then equal sign 1.3933. So 1.3933. So if you double check now, the 2 decimal places answer, right, for this one, it should be 1.39. And then for this also, it will be 1.39. So by right now, this will be your roots already. And usually for me, I want it to be safe. Then I will continue for another iteration. All right, so just to confirm, all right, so calculate again. Then 1.3933 equal sign. So I have 1.3908. So 1.3908. And again, if you double check the 2 decimal places answer for this one, you'll get 1.39 as well. Okay, so this actually already helps you to conclude that your final root is actually 1.39. All right, so from here you can see that besides the first initial value, like the initial value, all the iteration here I'm putting it in 4 decimal places, and the root must be in 2 decimal places as requested by the question. All right, so this is what you have for our 7 part C. All right, so question number 8. Okay, so question number 8, they give you the origin O and the points AB having the position vector by something like this, okay? And then the line L has equation R. Okay, then first question, they want you to find the acute angle. So the keyword is acute. All right, acute angle means that it appears in the first quadrant, right? Between the direction of AB and L. Okay, so to find out the acute angle, right, you need 2 direction. So the first direction given is already, they tell you that they want to find out the direction for AB and also the direction for L. So L is actually the line. Okay, so the direction in the vector equation, right, is only the part, okay, at the end of the vector equation. So this is the direction of L. So we are going to use this part only, okay, to calculate the acute angle later. Okay, so now we need to find out the AB. Okay, the direction AB, of course, you need to do some basic calculation, right? So how to get the direction AB? So you can take AO plus OB. Okay, so I'm putting it in the column vector form. AO means -1, -2, and -1. Okay, it is given here, right? This is OA. So AO means you change it in the direction, become everything negative. Then OB will be 3, 1, -2. All right. Then when you do the calculation for this part, eventually you are having 2, -1, and also -3. So this is the direction of AB. Okay, so you already have the direction AB and you also have the direction of L already. Then you can start with the calculation, okay, for acute angle between these two directions. Okay, so what is the acute angle formula? So generally you are having AB dot P. Okay, so where P, I refer it as the direction of the line L. Okay, then equals to the modulus AB modulus for P. Then you are having cos theta. So you want to find the cos theta here. Okay, so AB dot P, I'm having 2, -1, -3. Okay, then dot P, the direction for P will be 1, -2, 1. Then modulus 2 square plus -1 square plus -3 square. And then the square root for P will be 1 square plus -2 square plus 1 square. And then cos theta. Okay, then you just try to do the dot product. Right? So the dot product will be 2. 2 multiplied with 1, you get a 2. And then plus -1 multiplied with -2, you get a 2 also. Then minus 3. And it is equals to square root. Simplify everything inside the square root. So you're having square root 14 multiplied with square root 6 and then cos theta. Okay, so if you continue further from here, you will have 1 over square root 14 and also square root 6. And therefore, if you want to calculate the angle, so you have to bring the cos over. All right, so become cos inverse. Press calculator, you'll get that your theta is equals to 83.7 degree. All right, so for this question, they didn't mention whether they want it to be in degree or radian. So it is not wrong if you put your answer in the radian form. Okay, so if you get the answer for radian form, it will be 1.46 radian. It should be 1.46 radian. 1.46 radian. All right, so this is what we have for question number 8, part A. All right, then now we continue further for part number B. Okay, so for part B, okay, so they said they want you to find the vector position of point P on L such that AP equals to BP. Okay, so now since they mentioned that P is on the line L. Okay, so we have the line L in the question. So this is the line L. All right, so when we substitute a value into the lambda here in the line L, you will get a point on the line. So that is the point on the line, okay? So which means that if let's say I want to write out the position vector of OP, since I know that OP lies on the line, therefore I can assume that this lambda here can be some other unknown or some other variable. Okay, then we want to find this variable so that we know the location of the P on the line L. All right, so OP can be written as 2 plus S. Okay, then 3 plus S. Oh, sorry, 2 plus S and then 3 minus 2S. And then 1 plus S. Okay, instead of lambda, if you want to use lambda also no problem, but I will just put it as other letter here so that you know that S is actually a particular value for P that lies on the line. Okay, and we want to find the S here. Okay, so now I will bring this position vector of P to part number B. Okay, so again, for the position vector of P, I'm having OP. As what I written just now, you will get 2 plus S, and then 3 minus 2S, and also 1 plus S. Okay, so in the information that they give us here, they said AP equals to BP. So AP means the length of AP, the length of vector AP, the length or modulus of vector AP. okay, equals to the length or modulus of BP. Okay, all right. So before you find the length of the vector, right, you need to find the vector first. So I want to find the vector AP first. Okay, so what is AP? AP means AO plus OP. So again, AO will be -1, -2, -1. Then plus OP. What is OP here? 2 plus S, 3 minus 2S, 1 plus S. Okay, so your AP will be given as 1 plus S, 1 minus 2S, and then S. So this is your AP. Okay, and then now we calculate the BP here. Okay, so BP means BO plus OP. So again, BO will be -3, -1, and 2. Okay, then plus OP is the same. All right, then you'll get -1 plus S. Okay, then 2 minus 2S, then 3 plus S. Okay, so you already get the vector of AP and also the vector of BP. Now, we want to get AP equals to BP. So how to get the length of AP? So again, it is the modulus of vector, right? So how to get the modulus of vector? You will have 1 plus S squared plus 1 minus 2S squared plus S squared. So this is the modulus of AP equals to the modulus of BP. So -1 plus S squared, then 2 minus 2S squared, then 3 plus S squared. Okay, then because of this, both sides also have modulus function, therefore you can cancel them off. All right, then you expand everything. Okay, so after you cancel off the square root and expand everything, the left hand side you have 2s squared, 6s squared minus 2s plus 2. Okay, that equals to 6s squared minus 4s plus 14. Okay, so you should come to this step here. Right, you should come to this step here. After you cancel off the square root, expand everything, left hand side and right hand side, then you simplify them. So this is what you get for left hand side eventually, and this is what you get for right hand side eventually. Okay, then if you further simplify, you'll get 2s equals to 12. All right, and therefore your s is equals to 6. Okay, but the s equals to 6 is not our final answer, because for this question they want us to get the position vector of P. So that means you need to substitute the s equals to 6 back into the OP vector. All right, the position vector. Okay, so OP is equals to what? So the OP will be equals to 2 plus 6, 3 minus 2 times 6, and then 1 plus 6. Okay, so eventually your OP will be 8, -9, and 7. So this is the position vector for OP, or you can write it become the IJK form, where you will get 8i minus 9j plus 7k. So you can put it in any form like this. Alright. Okay, so this is what we have for our question number 8, part B. Okay, so question number 9. Alright, they give you the equation of a curve, something like this. Okay, and then you should know that because inside got ln x lah, so that means the domain defined for this function will be only x more than 0. Okay, the curve has one stationary point, so find the exact coordinate of the stationary point. So again, the stationary point can be maximum point or minimum point, and they want to find out the exact coordinates. So exact means that your final answer cannot be in decimal place. Alright, so you have to keep it in an E form, pi form, or sub form. Alright, okay, so it involves the stationary point. That means when you want to find the maximum or minimum, you actually need to do the differentiation. Okay, so this is our original equation here. Alright, so it is actually the product of two separate functions in x. Okay, so when you want to do the differentiation, you have to apply product rules. So which means this one is the first bracket lah. So the ln x will be the second bracket. So to do the differentiation, what you do is that you copy so you differentiate the first bracket, copy the second bracket first. So when you differentiate x power -2/3, you pull the power in front, copy back the x, the power -1 become -5/3, and then ln x you just copy. Okay, then plus, now you do the other way around, you copy the first bracket, differentiate the second bracket, you're having 1/x. All right, differentiate ln x, you get 1/x. Okay, then if you want, you can try to simplify it first. Okay, so I'm having something like this. And then for the second term here, all right, x power -2/3, then divided by x, that means -1. So the power -1, it will become x power -5/3. That means power -2/3 divided by x means that divided by x power 1. So the power you just minus. All right, so you have power -5/3. And then from here, right, you can see that there are some common terms here, which is x -5/3. So you can factorize it out. Then you are having -2/3 ln x plus 1. Okay, then when you want to find the stationary point, generally you need to let it become 0, right? The dy dx becomes 0. Okay, so you are trying to solve e power -5/3 equals to 0. And you're having 1/x power 5/3 equals to 0. So for this one, you have to ignore it because you will realize that there's no solution for the x. Okay, then now you will let also -2/3 ln x equals to 1. Plus 1 equals to 0. And you will continue to have something like this. 2/3 ln x equals to 1. Ln x equals to 3/2. Okay, and therefore to get the x, you need to move the ln over, become e. So you're having e power 3/2 or e power 1.5. Okay, so this is actually your your coordinate x. But they want to have exact coordinates, so that means you have to find out the coordinate for y as well. Okay, so to get the y, you will have e power 3/2. This is your x, right? Then power -2/3. Then you're having ln e power 3/2. So what is the y coordinate that you will have? All right, so you want to multiply the power inside. Okay, so when you want to multiply the power inside, then you're having e power -1. Okay, then ln e power 3/2. Ln e is a 1. Then the power, when you put it in front, it will become a number, which is 3/2. Okay, and therefore your y will be equals to 3/2 e power 1. Therefore, the stationary point coordinate will be e power 3/2 and also 3/2 e power 1. Okay, so this is the coordinate, exact coordinate for the stationary point for part A. All right, okay, then now we continue to part number B. Okay, this is what we have for part B. So part B, they involve the integration. They want you to show that when you want to integrate the function y from 1 to 8, this is the final answer that you can get. All right, so again, let us start. Okay, so what is my integration here? Right, I'm having 1, 8, then y is x -2/3 ln x, then dx. Okay, so again, if you look at the question here, right, the integration expression, you are having two different types of function. All right, so for this one, x power -2/3, it belongs to algebra. Then ln x belongs to ln, so logarithmic function, so it is L. All right, then when you want to do the integration by part, because this one you have two different type of function. So when you want to do the integration, you must use integration by part. Okay, then for the integration by part, you have to decide which one is u and then which one is dv. Okay, so to decide which one is u and dv, you follow the rule for L, I, A, T, E, right? Okay, so that means if your function is more to the left hand side, then it is u. Then to this side, it will be dv. Okay, so if in my question here, you can see very clearly that A, okay, is in the center here, and then L, the log function, is at the first place. So the first place, we will assume that it is the U. And the later one, the A, will be the dV. Okay, so which means if I want to write out my solution here, my step, I will write it out like this. So U is equals to ln x, okay, and then dV is equals to the rest of what you have here, x negative 2 over 3 dx. And mainly you want to do the integration. Then this part you want to do differentiation. Okay. All right. So how to do the differentiation for u with respect to x? So you're having du over dx, which is equals to 1 over x. Okay. Then when you want to get the integration of dv, you have a v. Okay. Assume that this is a 1 here. And then integrate x negative 2 over 3. So when you want to do the integration, you plus 1. Power plus 1, it will become 1 over 3, right? Okay, then divided by 1 over 3. So if you further simplify, you will get 3x power 1 over 3. So this will be the u and v that I want to use to substitute it in integration by part formula later. Alright. Okay, so to do the integration by part, the formula will be uv minus integration of v du. Okay, and the question is integrate u dv. Alright, so we are going to apply this one now. uv minus v du. Okay, so again, what is your u? So your u here will be ln x. So you just put in ln x first. What is your v? So your v will be this one. After you do the integration, this is your v. So 3x power 1 over 3. And the limit for this part will be 8 and 1. Okay, so you assume that you already finish the integration for this part. So you want to now at the stage to substitute the value. Okay, then minus integration, you just copy the integration, copy the limit as well. Okay, now you want to integrate the v. So where is the v here? So the v is this one, right? So 3x power 1 over 3. Okay, then du. What is your du? So to get the du, you have to refer here. Du over dx is 1 over x. Therefore, the du will be 1 over x dx. Okay, so you try to substitute everything here. Then, of course, you have to substitute all the value also. Okay, so the next step will be substitute the 8, limit 8 into the function, the expression here. So you have ln 8. Okay, then multiply with 8 power 1 over 3 is a 2. So 2 multiplied with 3 is a 6. Okay, then minus ln 1. So if you substitute ln 1, you get a 0. Okay, and so for this part, right, for this part, I will put the 6 in front. It is actually 6 multiplied with ln 8 and then minus 0. So this is what we have for the first part of the expression. Okay, then now we want to do the integration for this part. Okay, before I do the integration, I will try to compile everything again. X power 1 over 3 divided by x, you have x power negative 2 over 3 again. All right. Okay, then now you want to do the integration for this. So power plus 1 become 1 over 3 divided by 1 over 3. And then substitute the limit 8 and 1. Okay, all right. Then again, I will try to copy the first term in front. I'm having 9. Okay, so 8, substitute 8 inside the x power 1 over 3. You get a 2 minus 1. All right, so we are almost there because we already completed our integration. So what we need to do now is we have to rephrase our answer into the pattern that they want, which is 18 ln 2 minus 9. Okay, so I already have the minus 9 at the end of the answer. Okay, so what we need to do now is try to change this one become 18 ln 2. All right, so ln 8, I want to change it become ln 2. So 8 and 2, what are the relationship between them is actually 2 power 3, which is equals to 8. Okay, and after that, the 3 you can put in front to multiply with 6. So you have 18 ln 2 minus 9. So this is how we get the answer that day 1. Okay, so for this question part, question number 9 part B, generally we are applying the integration by part technique, okay, to complete the integration. Okay, so we come to the last question, question number 10. Okay, they give you a differential equation, right? Dx over dt equals to something like this, okay, and then they give you the value, right? The initial value. Then by using partial fraction, so again they already hints you that you have to use partial fraction to solve the differential equation, okay, obtaining the expression for t in terms of x. All right, so okay, maybe the very first step is we have to try to rephrase our differential equation first. All right. Okay, so we want to group all the x to one side, all the t to one side. So if I want to group all the x to one side, I will have 1 over x squared, then 1 plus 2x dx is equals to dt. Okay, so that means the whole terms, the whole expression on the right hand side, I move it to the left. Okay, it become 1 divided, all right? Then the dt, you bring it up, become multiply. All right, so for this one, generally you want to do the integration. Okay, all right, then now, because they already hint you that you have to use partial fraction, so that means now for this part, you have to carry out the partial fraction process first. Okay, so maybe I will write it on the right hand side here. Okay, so originally I'm having 1 over x squared, and then 1 plus 2x. Okay, so 1 over x squared, the x squared here we will treat it as a repeated factor. So for repeated factor means that you need to write out 2 times. Okay, the first time is over x, the second time is over x squared. So it is what we call as repeated factors. And then the third terms will be c over 1 plus 2x. All right, then I multiply the whole equation here with the denominator on the left. All right, so I'm having 1 equals to ax 1 plus 2x plus b 1 plus 2x plus cx squared. So my aim now is to find out all the value for a, b, and c. Okay, so to find the a, b, and c, first I will let x equals to 0. When I let x equals to 0, the whole equation here, left hand side, it is still a 1. Okay, so for the right hand side here, when you substitute x equals to 0 in this part, the whole thing related to a will disappear. Okay, because the whole thing here, the whole term here becomes 0. Okay, then the c also become, the whole term related to c also becomes 0. So I have only this part left lah. So very obvious, you can see that b is equals to 1. Okay, then the second value, I will let x equals to negative 1 over 2. Okay, when I let x equals to negative 1 over 2, again, left hand side, it is still a 1. It is not affected. Okay, when I let x equals to negative 1 over 2, you can see that if I substitute into this bracket, this whole bracket will become 0, and the whole term here will disappear as well. Okay, so the same thing happens for this bracket also. All right, if I substitute the value negative 1 over 2 into this bracket, this whole bracket becomes 0, and the whole term here disappear. So the last one exists is this one. Okay, the last term here, negative 1 over 2 square, you have 1 over 4, and therefore you have 1 over 4c. So from here, you will get c equals to 4. All right, so you get a b already, you get a c. Then now you want to try to get an a. Okay, so since just now you use 0, you use negative half, right? For now, the third value of x, you can use any value that you never used just now. All right, so maybe for this one, to make the calculation easier, I will put it as a 1. So the left-hand side is still a 1, not affected. Okay, then for the first term, 1 and 1, so it will become 3. 3 multiplied with a, you get 3a. Okay, then plus, you go to the second term, substitute x equals to 1 into this one. So you're having 1 plus 2, which is equals to 3. 3 multiplied with b, which is a 1, you get a 3. Okay, then plus 1c. So c is a 4. Okay, so from here, if you try to rephrase everything, then your A is actually a -2. So that means your partial fraction answer is out, which is 1 over x squared. All right, then 1 plus 2x. It is actually equals to -2 over x plus 1 over x squared plus 4 over 1 plus 2x. So this is the answer for the partial fraction. Alright, then now I want to substitute the answer from this partial fraction back into my calculation here, the integration. Alright, so that means I want to integrate -2 over x, okay, and plus 1 over x squared plus 4 over 1 plus 2x. And it is equals to integrate t. Okay, so we can start our integration now. So you integrate terms by terms. All right, so integrate -2x, 2 over x, you have -2, and then ln x. All right, then plus, okay, the second term here, actually you want to integrate x power -2. So when you're having x power -2, when you want to integrate, you add the 1 at the power. So it becomes power -1 divided by -1. And then plus 4, integrate 1 over 1 plus 2x, you have 1. Then 1 plus 2x divided by the differentiation inside this bracket. Okay, the differentiation inside the 1 plus 2x here. Then you have a 2, so divided by 2. And it is equals to t plus c. Okay, so this is how we do the integration. And now I will try to simplify it. And then we want to find the value for the c, the constant c. Okay, so for me, I will just try to rephrase everything. Right, I'm having 1 over x plus 2, then ln 1 plus 2x, then equals to t plus c. Okay, then now I want to find the c. Right, so to find the c, I will need to use the initial value given in the question. They said when x equals to 1, t is equals to 0. Or when t equals to 0, x is equals to 1. All right, so if you substitute it into the equation on top here, okay, what do you get from this equation? So you're having -2. All right, so I substitute x equals to 1 here, right? So -2 ln 1, this one will become 0. So substitute this one, you will get -1 plus 2 ln 3, right? Okay, and it is equals to c. All right, so that means your c will be equals to this, okay, this value. And now you try to substitute it back into your answer. Okay, your integration answer. So you're having -2 ln x minus 1 over x plus 2 ln 1 plus 2x equals to t. Then the c is -1 plus 2 ln 3. Okay, so maybe some of you might ask if your plus c is here, not here. So what is the value? If your plus c is in green color on the left hand side, then it will become 1 minus 2 ln 3. It will become 1 minus 2 ln 3, the opposite. Okay, all right. So this is the difference. If let's say your plus c is on the left hand side. Okay, then after that, you want to rephrase everything here because the question requests you to rephrase your answer t in terms of x. So for me, I will prefer to keep the t on the left hand side. I will bring everything over to the right. All right, okay, so t, okay, then I will have, if I rewrite my equation again, okay, maybe I can do it like this, -2 ln x minus 1 over x plus 2 ln 1 plus 2x, -1 move it over, become plus, then -2 ln 3. Okay, all right, so now I want to take note on all this ln. Okay, I want to take note on all this ln, and I want to combine all of them together into a term that involve ln. Alright, so how can I group them together? So for the positive one, I will just put it in front. So let's say for this one, it is a positive value, right? So I will put it as ln 1 plus 2x power 2. That means the coefficient in front of the ln, I can bring it back, become the power. Okay, then minus 1, I just remain it as minus. The same thing happen, the square, I will bring it back as the power. And then ln 3, okay, the square, the 2, I will bring it back as well. Okay, so some will say that if let's say you don't want to bring it back, is it okay or not? Also can. If you don't want to bring it back, then you can factorize it out. Then it's easier for you to do the combine also for all the terms. All right, so maybe if for those who prefer to just factorize it out, then you have 2, and then you have ln 1 plus 2x, okay, then minus ln x, then minus ln 3. So up to you, like which one you prefer, then you just go ahead with the method that you prefer more. Okay, then I still have negative 1 over x plus 1. Okay, all right, then now, how can I group all the ln together? The term is about the ln. Okay, so if you want to combine them together, positive one will be on top as the numerator. All the negative in front of the ln means that it will become the denominator. So that means the x and 3 will be at the denominator. So that means they multiply each together, so become 3x. Then minus 1 over x, then plus 1. So this is why we have t in terms of x. Okay, so here we completed our May June 2021 paper 3-1.